Hello everyone, welcome back to Code Magic Infinity. Hope all of you are doing great. And today we are going to be solving Leetcode 509, which is Fibonacci number. Now, this is a common problem to anyone who begins with dynamic programming because it covers a lot of concepts like top-down approach, bottom-up approach, memoization, recurrence relations, all of these things which are like jargons when we talk about DP, and it covers it in such a simplistic manner as well that I think once we understand this problem, it becomes easy for us to at least understand the fundamentals of DP and what exactly is the benefit which comes with it. So without further ado, let's get started. So the problem is the Fibonacci numbers, commonly denoted as f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones starting from 0 and 1. That is, if f of 0 is 0, f of 1 is 1, then f of n is f of n minus 1 plus f of n minus 2. So basically, they have given us the base case as well, and they have also given us the recurrence relation. And all we have to do is take it and run with it because major things which we need are already given to us, right? So okay, before we start coding, let's look at how a Fibonacci sequence will look like. So we know that the 0th number is 0 and the first number is 1. So they have given us the base cases. And then after that, when we need to build from it, like for n equal to 2, what is going to be the second Fibonacci number? It's going to be the sum of its preceding two numbers, which is 0 plus 1. Similarly, what's going to be the fourth Fibonacci number? It's going to be the sum of the previous two elements, which is 1 plus 1, 2, and so on and so forth. So basically, we have f of n equal to f of n minus 1 plus f of n minus 2. So there are two ways in which we can solve it. Either I can say that, okay, I need to calculate f of 4. So I can say that, okay, if I want to calculate f of 4, then I'll first calculate f of 0, then I'll calculate f of 1, I'll calculate f of 2, and then finally I'll calculate f of 3, and we know the sum of f of 2 plus f of 3 will give me f of 4. Now this is a bottom-up manner, which is definitely an approach you can use, and this will give you the solution. What we can also do is we can actually do it in a top-down approach. So let's quickly see how the top-down approach will look like. So I see that, okay, I need to calculate f of 4, okay. Now I work my way backwards. So, okay, for f of 4, what do I need? I need f of 3 and f of 2 because that is my basic recurrence relation. And for f of 3, what do I need? I need f of 2 and f of 1, again following the same recurrence relation, right? So this is basically the recursion tree. That's what I'm trying to draw out for you just to understand how it will look like and what are the potential function calls we'll be making if we try to code it up recursively, right? And similarly for f of 2, again, I'll need f of 1 and f of 0, right? So this is how the tree will look like. Why I have stopped at f of 1 and f of 0 is because these are my base cases. I know the values of these, so I don't really need to calculate them further. And as you can see, there are certain function calls which we are making repeatedly, right? So for example, we calculate f of 2 here, but we are looking for f of 2 here again. Now, do we really need to calculate it again? No. If we can save this result, then obviously it will save us time and we can directly return the output for f of 2. Similarly for f of 1, f of 0. And that is basically the beauty of memoization, or basically storing the output as and when we get and reusing it, right? So ideally, f of 4, if we look at this recursion tree, you would have seen that it would actually be of height 2 power n, because if we were not storing the results, there would be 2 power n computations we would be doing. But now, since we decide to store the result and reuse them as and when we require it, or everything will be calculated only once. So f of 4, f of 3, f of 2, f of 1, and f of 0. So basically, this 2 power n now comes down to just n. And that's like a massive saving we get just because we did a simple thing. We decided to save our intermediate outputs, reuse them, and that's the power of dynamic programming. So yeah, just wanted to visualize this top-down approach. Honestly, I always like approaching problems in a top-down manner because somehow they seem a lot more intuitive to me. But of course, there are problems where bottom-up approach works better, and there are problems when top-down works better. It does differ, but yeah, I think this way of understanding things, that okay, how I am saving the results, how 2 power n is coming down to n, and that's how memoization helps a lot. I think as a beginner for DP, or as a beginner of even data structures, it really helps to put things in perspective. Yes, I think enough said, and now let's quickly jump into the code. So what I'm going to do here is I'm first going to create a helper function. Okay, so let's see. Let's call the helper function, which will actually do our calculation. Okay, so this helper function will take n, obviously the value of n for which I need to calculate the Fibonacci output, and I'll send an empty dictionary, because what I'm going to do is I'm going to save the intermediate results in my dictionary. So basically for 0, I'll save the result like this, like f of 0 is 0, f of 1 is 1, f of 2 is 1. So I'll save the results in my dictionary, and that's why initially the dictionary is empty, and as and when I compute the values, I'll keep adding it to the dictionary. So let me now call this fibdp of function, and it will take n as well as the, let's call it fibdict as the argument. Okay, and I always forget this, self as another argument. Right. Now, the base case is first, if n is equal to 0, return 0. If n is equal to 1, return 1. If n is already present in my fibdict, then I don't need to recalculate it. Return fibdict of n. Okay, let's, yeah, that's correct. And if not, I will first memoize it, or I'll save it in my dictionary. Okay, so it will become fibdict of n minus 1 plus fibdict of, oops, my bad. It will become self dot fib dp, yeah, fib dp of, we are basically invoking the fib dp function on n minus 1 and n minus 2 as well. So let's call it fib underscore dict here. Yeah, plus self dot fib dp of n minus 2 comma fib underscore dict. So basically, for if I want to calculate f of 4, then I need to calculate f of 3 and f of 2 as well. If I need to calculate f of 3, I need to calculate f of 2 and f of 1 as well. So we recursively keep invoking the fibdp function and keep memoizing the results as well, so that I'm not making the same computations again and again. And finally, we can return fibdict of n. So I think this should do it. Yeah, let's try running it and see if we are onto something or not. Oops, so this is fibdict and fibdict. Okay, so this seems to be running fine. Let's submit it. There we go, it's submitted and we are good to go. So yeah, I think this was a very simple problem, yet I believe a good problem to begin understanding DP. If you were able to follow through, if you enjoyed watching the video, please do like the video and also subscribe to the channel. In case there are any specific problems which you would like me to solve, do let me know. Thanks again for watching the video. Thank you. Bye.